Now we do have our last presentation of the day, which is from AVI-CON. They are one of our sponsors, but also the products that they offer gives us the capacity and the ability to be able to reuse and strengthen and maintain some of the existing building stock that we have, which is extremely important. We do have a growing global population. We do have a massive carbon footprint due to new construction, and so we need to think a little bit outside the box. So knowing some of the products that they have available, I think could be very useful to all of us.
Thank you, Shalini. Um, so the theme of this presentation is stakeholder engagement to achieve a sustainable built environment. And this is actually our company motto, is bridging the gap to a sustainable built environment. I am not an engineer. Yesterday, Eric introduced himself as being an engineer. I am not an engineer. I, unfortunately or fortunately, am a physicist, so I was on the other side of campus. I have a master's in marketing and a master's in sustainable energy management, so I understood a lot of what you all were saying. I've written papers on some of the things that, or contributed to papers and so on some of the topics from a sustainable energy perspective. I grew up in the construction sector and the manufacturing sector in Trinidad, and while at TCL, I was in charge of the construction sales to the technical industry, and I realized that there was a serious problem where we had good technology, we had good products, we had bad application of good products, and we have good products or good applications of wrong products. And a lot of the times when failures occur or systems go wrong, the suppliers or the engineers or the clients face with this challenge where we have to rebuild, redo, replace, and it plagued us, and especially now in a time when we have to do more with less, we were driven, my family and I, to find solutions, and hence we formed this company, and we went after some of the more sustainable things. So we do not sell, or while we do sell, we do not sell, like, don't go after all the retail products. We aren't really driven by making all the money or having all the market share, but the guys in here who know us know that we go after sustainable projects and solution-driven projects and so on. So this is really what I just said. So we represent a few of the larger companies in the world who do engineering products. Here we have a division of one of the companies called WABO. We do engineering joints. And the reason this is important to me is one of the first international training sessions that we took engineers from the Caribbean to. We took them to the WABO Institute in Buffalo. And the reason for that was that there were some bridges that needed finger joints. There were some government campuses that had leaks at the roof. And there was a big hotel chain that had 20 inches of drift at the top of the new wing that was going to be added onto it. And the structural engineer on that particular project, when he approached us for the solution, was very happy that we were able to help him do the 3D modeling at WABO for the project. So some of the guys in here and ladies would have gone to that facility and been exposed and trained in some of the WABO products. So that's why we're here. And Shalini would have, at some point, I think yesterday, mentioned the need for collaboration and support. And without knowing it, my presentation is really geared towards how we collaborate with the industry, with your sector, to deliver the objectives and the value that the stakeholders look forward to. So the one on top was used on our government campus that was plagued with leaks. It's a pot-type floor system, and there were 4-inch and 6-inch joints in it, and they've constantly tried to repair it. It was built by Wimpy, I think about 30 years ago. So your theme is 30 years past and 30 years forward, and we were able to repair a 30-year-old joint using that system on top. That's called the WABO ME. I think it was the 625 we used on that case. The one on the bottom right, yeah, that'll be your right. It's something that people in Trinidad get annoyed with. It's on the bridges and the bus route. And those were installed about 20 years ago. But because of paving above the plane of the joint, the impact loads no longer go through the shock absorbent material that we see. That's a shock absorbent polyurethane concrete to prevent the transfer of the direct loads, onto the joint and acts as a buffer as the wheel loads hit the joint. But because in Trinidad, milling of the high wheels wasn't a popular practice, we continuously paved, and then the elevation changed. And the loads went onto the joints, and the joints started to fail. So we're actually working with the agencies to help reinstate these joints. We've done one pilot project with them already. This morning I went to see 2 others, and a bridge program is coming up where they'll be doing over some of these joints and changing some of the type of joints. The one closer to the verbiage, that's the type of joint that is specified for the hotel building. Those, I think, have up to 30 inches of drift in that particular building. On the 15th floor, it was 20 inches of seismic drift in a 3D plane, so this is allowed to oscillate in 3 dimensions. Okay, yesterday you may have seen me around. One of my suppliers was here. That's Chris from Avanti. In this case, this is Master Builders Products. This is a tank in the petrochemical sector where the base had subsidence. The site of this tank had superimposed loads that would drop from a crane to compact the site. If anybody's familiar with it, I'm not allowed to say the company. But the tank was built outside of that zone where they had the compaction that occurred. And I think there was an error, and this tank sank. There were major options considered. CBI, Chicago Bridge and Iron, was contacted to dismantle the tank and reinstate the base. Paramount and Junior Sammy were asked to bring in big cranes to lift it off, retrofit and lift off the tank, and then do over the base. Tucker and Schlumberger were asked to pump mud and other stabilized material underneath the base. And one of your members actually worked with me on that project, and we sent the engineering design for the pumping and a pumping plan to the foreign engineers, and it's from one of the highest technologically advanced countries that reviewed one of your local engineers' work, and they approved it. So in this case, we had to air freight in the thing because it was on a critical part from preventing the plant from starting up. We air freighted in the materials. Within 2 shifts, we were able to pump it, and we lift the base back in place. It's an ultra-fine, high-performance, long pot life or long slump life grout that we use in this case. And again, it happened because we collaborated with one of your engineers who supported me in this venture to get this job done. It's the first time, to our knowledge, that this was done. We're currently trying to have it done in Petrotrin, well, not Petrotrin, but Paria and those tanks. You know, recently there was a failure of a tank that was being pressure tested in the old Trinidad site, and it was a similar failure of the ring and subsidence at the base that caused it. So we are currently speaking to some people to try and have that technology utilized. Again, it will save on the built environment and reduce the cost of building over and doing over all these tanks and so on. With new construction, we have a host of products. The bottom picture there, I think Beston and some other people will be very familiar with it, Ministry of Works. That is the betum. There were crossings there. This is one of my first projects once I ventured out on my own. The challenge here was that this is the main artery into the city. There were about 5 crossings that needed to change with culverts. They needed to get 26 newtons in 6 hours in order to make the schedule so that they could reopen the roads on Monday morning. Junior Sammy was the first culvert. We were able to achieve, I think, 28 newtons in 6 hours on Thursday. By Friday, we were making concrete to put into the culvert. By Monday, the job was reopened. That concrete was batched in Claxton Bay, and we helped them design the power plant. A special retarder was used at a very low dosage rate where we calculate the number of cycles that the truck would actually rotate the mixer, bring it up to the site and then introduce, combine with other additives to accelerate the setting time of the concrete. Again, this was done in combination with local engineers as well as our technical support from master builders. The second project was even worse because we batched the concrete in Princestown by Lakshmi Singh and brought it up. Subsequent projects became easier because the concrete was batched in Arima, so it made our life easier. So that is a case where we use very high-tech admixtures to achieve very good strengths. People in the precast industry in Trinidad often suffer to get 3,000 psi, or that's what, 21 newtons in 18 and 15 hours. And we were able to get 26 newtons in 6 hours. In Guyana, we're using Master Exceed. That's an accelerator for precast. The largest precaster in Guyana now is able to achieve stripping strengths in 10 and 12 hours, and he is using about 15% less cement that we currently use in Trinidad. It's amazing because in Guyana, their sand is not as good as ours. They have high variability in sand, and the gradation is not the same. So it actually should cause us to use more cement, but by using the Master Exceed, and I think we use Glenium 3030 there, we're able to help the client achieve stripping strengths, which is 3,000 psi for some products and 4,000 for others in 10 and 12 hours. This here is a rheology modifier for self-compacting and flowable fill and self-compacting concrete. In Trinidad, it hasn't picked up, but there are applications for it. This is actually a project where we worked with PAHO. There's some stakeholders here who have been involved in that. The remarkable thing about this particular project, this picture here is flowable structural concrete with built-in inhibitor, corrosion inhibitor, and fibers. And the blue line that you're seeing around is a 24-hour pot life bonding agent. Sorry. So we were able to do larger repairs in shorter time with a very long pot life epoxy bonding agent. We are the only ones who have that particular product. And on this project, it was used throughout to make life easy and make the repairs faster. In this particular pour, the surface of the slab was intact, but the entire bottom was corroded. So instead of demolishing the entire slab, we shored it up and we poured the fill from on top, the concrete from on top, and it went into the entire bottom. And when we stripped the forms, we tested to see if there were any voids or any hollow points. We used the bonding agent on the underside, and the project still stands very strong today. Again, regional architects, regional engineers, and some of the elders of this organization were involved in that project. We spoke about corrosion MST spoke about corrosion. Savitri touched on lack of data. One of your members is actually working in Florida, and this is an extract from one of our training presentations on corrosion mitigation and corrosion management. And Florida is down by Miami, is probably 160 miles across. Trinidad is 36 miles across, I think. And if you look here, you can't see it, but this is 18.9, which is on the highest chloride ion content, and that is 169 miles across. Same Atlantic Ocean. So people think that in the middle of Trinidad or on the side of the coast where we have the Orinoco water, we're not subject to chlorides in the air, but at 36 miles, and the other islands that are even smaller, the entire island has a maritime climate. So salt is in the air and it's deposited. Why is it important? The guy who was from Trinidad and is now in Florida is employed at a company, and he speaks with me a lot about it because he would have gone on some of the training where we discussed this at length. A few years ago, there was an apartment building that failed, and that changed the way the asset management in Florida happens. To do any concrete repair or any structural repair, the engineer has to go through all the science and apply a work method or a repair method for every building to extend the life of the building safely. Um, so this type of data and the training that we would have offered, in fact, our companies, parent companies currently doing a lot of seminars and webinars with them to help guide them on the repairs for those buildings. And they're using our products widely in Florida right now. In terms of data, I am about to procure either 1 or 2 corrosion potential machines. We were going to bring it in earlier this year, but we had some changes in the direction of the company, and I did not buy it for Trinidad, but we're going to buy a couple, and we should be offering that service in Florida for that same company to help monitor the corrosion potential of the exposed concrete so that they'll know how extensive the chloride ingress and the rust and so on is in the concrete, and they'll be able to use data to guide their repairs instead of doing invasive quarrying and demolition to see what's happening. Once we have that, I did commit to Shalini that we will collaborate with you all. We should make it available. I spoke with some of the stakeholders in the industry already because the central bank is an exposed aggregate, exposed concrete building that's on the seaside. Mount Hope is similar, University is similar. A lot of the bridges have exposed concrete that are subjected to carbonation, chloride ingress. 30 years ago, we only had OP cement in Trinidad. And if you look at buildings that are exposed, right outside UWI Library, you see stalactites and stalagmites where the calcium carbonate leaches out of the concrete and deposits. Those are all signs of bad capillary action and open pores that are in the concrete. So this particular slide here is a product that Central Bank is considering to use. Recently, they would have used a saline siloxane water repellent on the building. What that does is just seals the pores for about 3 or 4 years, but it does not address the reinstatement of the passivating layer over the rebar, nor does it remove the chlorides that are leached into the concrete. So this slide, it's available when we do the other webinars with you all, shows the impact of Master Protect CR8000 on a cracked beam in terms of corrosion versus normal and versus saline siloxane sealants. So Master Builders has invested significantly in research into products and technologies that are geared towards extending the life of buildings and protecting buildings, which is again in line with what you all were discussing on the panel and some of the presentations from earlier. This for me is the star of the show for AVI-CON. This is carbon fiber retrofitting. IKK, I did a presentation for IKK once on carbon fiber in Val Park. Everybody who knows IKK know where we find him on a Friday evening. And one of his students, who considers IKK his guru, got a job in the energy sector. And he was there for the presentation. And one day I had a visit with one of my technical support reps from Master Builders, and he calls me. I said, Avi, I have a crack in a beam. You could come and check it? I said, no problem. So his boss in German says to me, Avinash, do you fix cracks? I said, well, yeah, we fix cracks. That's what we do. And then she showed us the cracks, and we said, this is a bad problem. We need to go and see it in real. So we went into the plant. We looked at it. There's a 450-ton vessel sitting on concrete beams that are 7 foot deep. You can see the size of the guy is here on the beam, next to the beam. And there's shear cracking, torsion, there's delaminations, there's concrete failure, there's corrosion. Members of your organization who were trained in the use of our systems did the retrofit calculation design, the condition analysis together with us. We proposed the retrofit design changes to the Germans who are responsible for the plant. The Germans were, wow, are you sure you could do that? I don't think we should do it. We said, what options do you have? One of them suggested load path transfer using structural beams, reduce the spans on the beams, use our sections and modify the foundations and go on. So the managing director of the company looks at us in a meeting and says, is he mad? I have to shut down that plant for 2 months to do that. Avinash, how long will you take to do it? 2 months. He said, you mad? I said, but I don't have to shut down the plant. He says, oh. So without a day downtime, which cost them over $500,000 a day, we were able to retrofit 2 sets of jobs. They gave us one. After its success, they gave us another one to do. And up to now, we go every year and we inspect the plant to make sure that it works. One of the major challenges that was unforeseen on this particular job was the vessels radiating heat. Those of us who are familiar with epoxies know that epoxy started gel at about 70 to 80 degrees Celsius. And for a structural retrofit, that's not good. So one of our products, which you will see later on, we coated these beams with it so that the radiant heat was reflected away from the carbon fiber and the beams. So that way, when we monitored the temperatures, it was still below 40 degrees Celsius. It was more ambient than anything being imposed from the vessels. To date, we inspect it, everything is good. This is a direct tensile pull-off test machine. So we have to do pull-off tests on the carbon fiber to make sure that we exceed 200 psi or 136 MPa, I think, or 143, can't remember. But we were held in high accolades by master builders because the code committee chairman reviewed this project for ACI 440 code. He reviewed this project, he checked the calculations, he checked the test data, and all of our pull-out strengths were either 1.7 to 2.3 or 2.4 times the minimum tolerance. So we exceeded the expectations on this particular project. Since then, on our PAHO project, we would have done this here. In Puerto Rico, it's now approved to use a similar layout to withstand flying projectiles and so on and on reinforced walls during a hurricane. So it's a method of retrofitting buildings for projectiles during a hurricane. We've done 7 projects with carbon fiber in the region, and all have been very successful. We have been able to save buildings, prevent the loss of the use of the buildings, because in some cases the retrofit would have meant significant downtime. It would have caused loss of headspace because they had to do the beams to support floors or columns. So we were able to maintain the architecture of the building, the functionality, and increase capacity or reinstate capacity. This is what the system looks like. Again, it's available, and we'll be doing seminars, so I don't have to go into it now. This is a car park grade waterproofing system. It's used on elevated car parks, patios, stadiums. There's a pedestrian grade as well as a vehicular traffic grade. It withstands ponding water, hurricane force winds, the sharing of turning tires on it. This is important because a lot of buildings are subjected to corrosion and water ingress and damage. We are probably on probably about our 6th or 7th car park that has started to use this product. We had one failure on a car park, 2 failures on the same car park. Again, for all the car parks, engineers are consulted. The project is designed. It's the process of quality control is implemented. Proper equipment is used for prep. We don't use grinders for prepping for car parks. We use a shot blasting machine. And we have 2 of them that we support our customers with. In the car park that had the failure, the ramp was designed at the wrong angle. So when cars turn in, the tow hook at the bottom of the car was cutting into the system. And for the first 5 feet of the ramp, the system is gone because it's sliced out by those tow hooks. So we're going to have to scarify that area to create some traction and use a crystalline waterproofing system. The other mode of failure that we experienced on that project was on that same ramp, the contractor cored 2 holes and poured fill to encase a beam underneath the car park that we weren't aware of. And they plugged the hole with concrete the week before we came on the site. One of the requirements of this system is that concrete must be cured for 28 days. 90% of shrinkage occurs in the first 28 days. And water vapor is emitted from the concrete within that 28 days. We installed this system on that car park about 2 weeks after the core was plugged. And those two cores, there's circular failures right over the cores. And in hindsight, the contractor was like, I didn't tell you that, but it happened. So now we know when we do our checklist or punch list for projects like this, we insist that any repair of that nature must come to our attention so that we could approve the methods. It's not a push for ourselves, but it's a push for our performance. So for example, we have repair systems that are not based on conventional cement, but other types of binders that allows us to put membranes on it after 5 or 8 hours of application. In the Paho job, we had a product, because there were some critical areas, I think that was 1060. It allowed us to put epoxy onto it the next day. So in that particular job, it was a fort that was converted to a hospital type environment, and it was done while the occupants were in the building. So they split the building in half, put some of them there, we worked on half, moved them across, and then did it. And because of that, we had to mix the materials to achieve the timelines that the client had. And the use of that type of repair material was critical in that particular project to achieve the schedules that they wanted. This is another type of waterproofing system. This particular system is white. It reflects 95% of incident heat. The primary reason for applying it on these buildings were because of leaks in the roof, in the concrete, spalling concrete, coastal, very near to the coast, so a lot of corrosion. There were joints. In fact, this particular building, one of your engineers worked on this and he told me, when I was an apprentice, I was on this job and I find the building was too long, so I put 3 joints. I said, did you calculate the movements on the building? He said, no, I just chop it and I put some 1-inch joints. I was like, okay, but every joint was leaking. So we had to use Wabo joints to fix those joints, but all the roofs, the rest of the building will be done again, will be completed. There's no leaks. The heat is reflected off of the building. The classrooms that are in red were not treated. The ones in white were treated. And last year, we had a heat spell around the same time of the year. It was very hot. In some cases, temperatures reached 40 degrees outside. The buildings in white were at ambient temperature. The buildings in red were unbearable. And the agency responsible for this has committed to convert all buildings under their care to the use of the system. The particular system used here has a 20-year life. So at about 20 to 30% of the cost of replacing the roof and putting a radiant heat barrier, we were able to extend the life of the roof by 20 years, waterproof it, and reflect the heat off of the building. It was all done without shutting down the schools and without having to interfere with the ceilings, electricals, or any other utilities. Again, that's another example of collaboration with the stakeholders to design a solution that benefits them in a sustainable way. Chris, who was with me yesterday, is from Avanti. And what we do with Avanti is chemical grouting. I know that we might have more civil applications for this than structural, but again, one of your engineers specified it for a project where a building was built on sand, deep sand, and when he did his analysis, the sands were going into liquefaction, and he opted for 1 or 2 of the products to be injected into the existing ground condition to reduce the liquefaction in and around the foundations of the building. So that is how this type of product could reduce liquefaction around some of those susceptible foundations. He was here because we had an emergency visit in one of the estate plants in Point Lisas. They have a foundation with a critical vessel on it that is experiencing punch through. If any of you all would have worked on the estate, the first 8 feet of the soil there is basically imported fill, and then it's between 100 and 120 feet deep before you get to bedrock or competent soil, and they have to pile everything. Some people build pad footings, so lighter vessels or lighter structures on this without reinforcing the soil. And again, this is a critical part of the plant that is susceptible to failure. So they're doing some temporary shoring, and we will most likely be approved soon to inject structural polyurethane expanding foam to increase the bearing capacity of the base by spreading the loads beyond the footing, and hence reducing the punch through that it will face. This also has applications in municipal waste, floor jacking. We spoke with Dr. Gay about using it for fissured rock up the islands. He specifically mentioned the Grenada West Coast Road. I think some engineers in Trinidad are working on that. Dominica, he says it's important. He said in one of the islands, every time a rock falls and kills somebody, they put a monument or a plaque. And then they say, okay, we're going to fix it. And it always gets kicked down the road. In Tobago, on the Windrun Road, he said it could also be used there, as well as some other applications. The Ministry of Works, one of their bridge engineers is also considering it. He identified 2 or 3 bridges where it can be used. We recently saw that there was a bridge in Perseverance where the soil became saturated underneath the bridge, and there was subsidence. Those are the type of applications for this particular type of technology. And again, this is another example of utilizing technology to extend the life of infrastructure without shutting it down for prolonged periods. We have also been talking to IKK about the use of carbon fiber to retrofit some of the existing bridges. One bridge in particular that he thinks it might be useful is the bridge that crosses the Caroni River near the Piarco Airport. Those have mass buttresses, or what do you call that, pylons. They're about 6 foot diameter, and he doesn't know what the reinforcement is. I think Trinidad contractors redid the deck about 10 or 15 years ago, but they never addressed the columns. So he's saying that he can increase the confinement of the piers or columns on the bridge using the carbon fiber. Also, the bridges that are going on the South Highway, where we have reinforced concrete decks, those were designed and built, I think, in the 70s. Again, Wimpy, I think, was the contractor on that. Carbon fiber can be utilized to increase the capacity on those bridge decks, and we're working towards trying to get some consideration for that. Yeah, I think that's it for some of the projects that we've worked on. These are only some of the projects that we've worked on where we utilize technology in collaboration with the stakeholders, the consultants, the engineers to deliver a sustainable solution. And again, it was purely by chance. After I got the agenda, I saw what the theme of this conference was, and we actually fall in line with it, where we looking towards improving the built environment to last longer and hence get more value from it. Thank you.